Good day, folks. Welcome to my YouTube channel. If you're new here, welcome. Please subscribe and stay tuned. I'll upload more videos that will assist you in your physical sciences. Those who are returning subscribers, welcome back. Thank you. Thank you so much for your support, guys. We are doing the trial of the Free State Province in September 2024. It's paper 2. It's the physical sciences. So I'm going to do the whole question paper. Just stay tuned, right? I'm going to do the whole question paper from multiple choice to question 9, which is the electrolysis. Cheers. Let's cut the chase. Let's start with multiple choice question. Question 1. It says here the condensed structural formula for an organic molecule is shown below. This is a condensed structure, guys, right? But it says the molecule is unsaturated, and unsaturated, it's a molecule that consists of a triple bond, double bond. But here, looking at this, there's no double bond here. It's just a branch structure. It's a structure like this, and then CH2 CH3. It's a structure like that. So it's not an unsaturated. Yes, it is saturated. Is it a straight chain? No. It is a straight alkene? No. This is not straight, and this is not alkene, right? So the answer here is A. Now let's move. Not A. Sorry, B. Now let's move to 1.2. Consider the organic structure below. It says here's the structure below, and if you look at this functional group, this is an what? This is an ester, right? So this ester, its name, if you can see here, this is going to be what? A methyl, right? It's a methyl E, and then this is going to be what? Ethanoate, right? It says an IUPAC name of its functional isomer. The functional isomer of this, it's going to be a what? An acid, a carboxylic acid. So it's going to be 3 carbons. It's going to be like that. The 3 carbons with that functional group there, right? So the name of this, it's going to be a propanoic acid. A propanoic acid, which is going to be that one. This is an ester already. They want each functional isomer IUPAC name, so it can be that ethyl methanoate. So which is they say it's an ester. The functional isomer of an ester, it's an ester, so it needs to be an acid. It's an ethanoic acid. This is not an ethanoic acid. This is a propanoic acid, right? So the answer there, it's B. Right, it says consider the following organic compounds. This organic compound, guys, we're given the condense here. It's a CH, right, with the CH2, CH3, 2CH, and here's another one. All right, and then we have CH2, here's the CH2, and then we have a CH, here's the CH, and then we have a CH3 in this CH3, that is a branch, and another CH3 there, right? So what is what is this? What is it? It says the correct IUPAC name of this. The correct IUPAC name of this, let's change the color and use black. Let's look at the longest structure first. It's 1, 2, 3, 4. So it's going to be butane, right? Let's double check if we did it correctly. It's CH, here's the CH. In this CH you have CH3, which is the branches. Here's the CH3 and the CH3, and then we have a CH2, here's the CH2 and the CH, here's the CH. And then in this CH there's a methyl, there's a methyl, and then another in this CH there's a methyl there. Okay, the longest structure is butane. 1, 2, 3, 4, 5. It's pent, right? It's pent. Okay, let's look at this way. 1, 2, 3, 4. 1, 2, 3, 4. No, man. It's 1, 2, 3, 4. That's shorter. 1, 2, 3, 4. What am I doing? 1, 2, 3, 4, 5. Right? So it's 1, 2, 3, 4. 1, 2, 3, 4. I don't know what's wrong with me. It's 1, 2, 3, 4, 5. Right? It's 1 this way. 1, 2, 3, 4. How's that possible? 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's 5 this way, 5 this way. It's 5 this way. You get me? Okay, let's get the easiest. So we're going to say, where are we going to? Okay, if we look at this side, let's take the parent is this. Let me do it black. Let's take the parent is this one. Right, so this is carbon 2, and we have 2 branches. We have if we're taking this with it carbon 2 1 2, we have a branch in carbon 2 as well. So it's going to be 2 with which side? If you do the left right method, left right method, left to right, so it's going to be 1 2, so we have a 2, and then 3 4, we have a 4 there, and then the right to left method, it's 1 2, we have a 2, and then 3 4, we have 4. So any side you start with. So let's say this is carbon 1 2 3 4 5, right? So we have a methyl in carbon 2, we have a methyl in carbon 2, so in carbon 4, so it's 2 comma 4, it's gonna be 2 comma 4 dimethyl pentane. So the answer here it's going to be this. So it can be that, it can be that, it can be that, it's that. So the answer here is C, right? Now 1.4, it says while a chemical reaction takes place, the rate of chemical reaction, what's happening to the chemical reaction? The rate of chemical reaction, it's not the same, right? It cannot be the same. It says a decrease because the rate of chemical reaction decrease because of the concentration of product decreases. No. Increases because of the concentration of reactant decreases. No. It says decreases because the concentration of reactant decreases. Yeah, once the concentration of reactant decreases, the rate of reaction is going to decrease. So the answer here it's going to be D, right? Now 1.5, consider the following. Let me use red. Consider the following hypothetical. Hypothetical is this one, it doesn't exist. So it says and then this reaction, it's an exothermic reaction because of the delta. So if it's exo, your graph it's going to be like that, right? It's gonna be like that. Now it says the activation energy of this reaction is 100. So the activation energy is from here to here, so it's what? It's 100, right? That's the activation energy. It says for reverse, so that's the forward. The activation for forward is what? Is 100. And then it says for reverse, the activation energy is gonna be that way, right? It's gonna be that way. So the activation energy is that. Do you see? This is bigger than this activation energy. So the answer here, we're looking for an activation energy that is greater, right? The activation energy that is greater. So is it going to be equal to 100? You can see these activation energy, they are not equal. Activation energy is going to be greater than 100, right? And then this is going to be wrong and this is going to be wrong. So the answer is 1.5 there. It says write down the conjugate base of that. The conjugate base of that is when it says donated that proton, so it's going to be, it can be that. You see, it has changed the oxygen there. It can't be that, right? Because there's one proton there. There shouldn't be a hydrogen, so it will be this one, because here the conjugate base, yeah, so 1.6 is gonna be that. So the conjugate base, this is the conjugate base and this is the acid, right? It can be that. So the answer is 1.6. Now it says the sodium hydroxide, which is the sodium hydroxide, is a base, is a strong base. It says it's turned blue to yellow. It turns bromothiamine blue, blue to yellow. No, it doesn't. Is acidic? No, it's basic. It turns phenolphthalein to colorless. No, it doesn't do that. And it's basic. That's correct. Okay. 1.8, it says a piece of magnesium ribbon reacts with an excess of hydrochloric acid. Here's the reaction, right? It says which one of the following is oxidizing agent. We know the oxidizing agent is the one that undergoes the what? The reduction, which is the gaining of electrons. So how are we going to know here? By assigning the oxidation number. The oxidation number of magnesium is 0. Hydrogen, it's +1. Chlorine, it's -1 there in that compound, so that they can make the 0 as the compound. Now for magnesium there, it's +2 because it's in group 2, and for chlorine it's -1 because it's in group 7, and then for hydrogen is 0. Now the oxidizing agent is the one that is reduced. How are we going to know is the one that is going to decrease the oxidation number? Let's look which one decreases the oxidation number. Magnesium, do you see, from 0 to 2, that means an increase. That means it undergo the oxidation. Let's look at hydrogen. Hydrogen, it's +1 and the hydrogen is 0. So that means there's a decrease in oxidation number there, right? So which one that oxidizes? It's H+, right? It's the one, the oxidizing agent, which is the one that is reduced. It's what? It's H+. So let's look at chlorine. Let's look at magnesium, which is the magnesium here is not an option. The chlorine, look at chlorine. The chlorine, it's -1 and it's -1, so it means it doesn't oxidize, it doesn't reduce, doesn't undergo the redox, so it's not. And then the hydrogen, so between these two, it cannot be this one, it cannot be this one, as we know that the agents are not here, the agents are here, right? And you see here it's H+ and this is H2. This one has been reduced to this. So the answer here is C, right? In 1.8. Let's quickly go to 1.9. It says in a galvanic cell, the salt bridge, you need to know the function of the salt bridge, is responsible for the charge balance to maintain the cells. Yes, that's correct. Let's see the other option. Allows the movement of electrons from one cell to another. No, that's not the function of the salt bridge. Allow the mixing of the two solution from different cells. No. Necessary what is it? Is not necessary for an optimal functioning of the cell. No. So the answer there in 1.9 is A, right? Let's go to the last question. Yeah. What is an energy conversion of an electrolytic? The energy conversion, it has nothing to do with mechanical. Do you see there? There's mechanical, it's electrical, and electrical and chemical in electrochemistry. So these two are wrong. So your options are here. But now remember, the electrolytic cell, we're using energy to produce the chemical. So this is not an answer, this is a galvanic, and this one is an electrolytic. So the answer there is A. Now let's quickly go to question 2. Question 2, it says letter A to E in the table represents the organic compound. This one is methane, which is an alkane, and this one propyl ethanoate is what? Is an ester, right? This one is an ester. Very important to look at them. Looking at this compound here, we have a hydroxyl there. That means this one is a what? Is an alcohol, right? And the propanol, this is a what? This is an aldehyde. Very important to identify what are them. 2-difluoro-2-methylpentane. This is a haloalkane. Haloalkane. Okay, now it says write down the letters that are representing a compound with a general formula. That this is a general formula for for an alkane. So the answer here in alkane is A. The answer here is A. And then the haloalkane, the letter that represents the alkane is E. The functional isomer of a ketone. Right? Which one is a functional isomer of a ketone? The ketone, its functional isomer, it's an aldehyde. So the answer is what? D, the propanol. It's D. So you don't write propanol there, you write D. Now it says for compound C, write it down. The type of alcohol it is, right? The type of alcohol it is. C. Let's look at C. We're going to the hydroxyl, looking at the hydroxyl, and look at that carbon. How many carbon that are attached to this carbon that is attached to the hydroxyl? It's 1, 2, 3. So that makes it a what? A tertiary alcohol. That's a tertiary alcohol, right? Now it says give reason for your answer. The reason for your answer, you will say the carbon atom bonded to the hydroxyl group. Hydroxyl group is bonded, as I've mentioned, is bonded to 3 other carbon atoms, right? As you can see, this carbon is bonded to 3 other carbons. That makes it a tertiary. The IUPAC name, let's go back to that. The IUPAC name of C, as we mentioned, it's an alcohol. So let's look at for the parent. It's going to be 1, 2, 3. No, 3. I'm very bad in counting. I don't even start the. You see, I'm starting here. 1, 2, 3, 4, 5, 6. I'm not sure if I counted right. 1, 2, 3, 4, 5, 6, 7. That's 7. That's the longest. So if you start here, it's going to be 1, 2, 3, 4, 5, 6. So the longest is going to be 1, 2, 3, 4, 5, 6, 7. It's 7. So our parent is going to be this way, right? So this is going to be, it's 1, 2, 3. The OH, it's in carbon 3. From this side, it's 1, 2, 3, 4, 5. So our carbon 1 is this, 2, 3, 4, 5, 6, 7. So naming this one, I'm going to name it here. I'm not going to name it down there. So we are answering 2.2.2. This is 2.2.2. So we're going to start with the branch. We have the branch here. So it's going to be 2. No, the branch is not 2. It's not in 2. It's in 3, right? The branch, it's in 3. It's in carbon 3. This is the carbon 3. It's 3 what? Methyl. And then what is the parent? It's what? Hapt. So we're going to say hapten because it's an alcohol. We have an alcohol functional group. So where's the alcohol? It's in carbon 3 as well, which is the hydroxyl 3-ol, right? So we are done with that. Let's go to name of its functional group. So the functional group of this, you can't say it's alcohol, guys. The functional group name of the alcohol, it's what? It's hydroxyl. It's hydroxyl what? Group. Don't forget the group. For compound B, write it down. Where's compound B? It's this one. It's an ester. It says write down the structural formulae of the 2 organic compounds that are formed. So if you look at this one, this ester, it's coming from the propyl, which is the propyl, it was an alcohol, which is, it was what? Propanol. In this one, it coming from an acid, it was ethanoic acid. So they wanted the structure. The 2.2.3.1, I'm going to start with the structure of the propanol. Structure of the propanol, it's going to be OH there. Right, that's the propanol there. And then the ethanoic acid. The ethanoic acid, it's going to be that. So what is important there is the functional groups, right? Is the functional groups that is important. That's what is important there. And then this functional group, that's what is important there. I'm not saying draw that alone, right? That's not what I'm saying. So you get the mark for the functional groups and for the whole structure. So that makes it 4 marks, right? Okay, now it says structural formula for the functional group of its functional isomer. So the functional isomer of an ester, it's a what? It's a carboxylic what? Acid. So they wanted the functional structure. It says what? Structural formula for a functional group of its functional isomer. So it's, you're just gonna draw here. Let me just answer it here. No, not that one, this one. So it's gonna be a structure for a carboxylic acid. Carboxylic acid, it's a carbonyl with the OH, and you must show that bond there. That is very important, that, right? You can do it this way as well. You can do it this way. The OH, your OH to be in this side and the bond to be in that side, it's the same. Now write down the structural formula for compound E. What is compound E? The compound E is this one, it's this haloalkane. So can I answer it here? It's 2.2.4. And the parent here is pentane. That means it's 7 carbons. Pent, it's 5. It's not 7. It's 5. It's 5 carbons. And then in the carbon 2, we have 2 methyl. So let's say this is our carbon 2. That can be your carbon 2. Doesn't matter. Let's have the methyl here, right? And then, guys, don't forget the hydrogens. I'm not gonna write them. We have a methyl there. That means this is carbon 1, this is 2, this is 3, this is 4, this is 5. So, and then we have in carbon 3, it says 3,3 difluoro. That means we have 2 fluorine in carbon 3. So we have fluoro there, and we have another fluoro there. I'm sorry for the space there, guys. We have another fluoro in carbon 3. This is carbon 1, 2, 3, right? And that's it. And then you show your hydrogens there. I'm not gonna do all of them. Okay, the 2.5. Now it says here compound A undergoes complete combustion according to the following. The compound A, it was a methane here. It reacts on oxygen, it gives the carbon dioxide and water. This is the combustion reaction, right? So it says during the combustion 2.75 kilograms of carbon dioxide is formed. So the carbon dioxide that is formed is what? 2.75 kilograms, right? Which is, when you multiply that by 1000, it's gonna be 2750 what? Grams. Remember, in chemistry, your mass, it must be in grams, right? Now it says calculate the mass. Very important. They want the mass of what? Of methane. So we want the mass. of methane needed for this reaction. How much was needed for this, the mass of this, to react with this to give you this and that? But specifically the 2.75 kilograms of the carbon dioxide. So what are we going to do? We're going to convert the mass of this into number of moles, and then we do the mole ratio of this is to that. So I'm going to write it here. The number of moles of what? Of carbon dioxide is equal to mass over molar mass. Guys, this is very important to show what number of moles are you calculating. All right, and the mass is 2 comma, no, we're gonna use this one. It's 2750 divided by the molar mass of carbon dioxide. It's carbon 12, and then the oxygen is 16. How many oxygen? 2. So when you punch that in the calculator, it's gonna give you 62.5 what? Mole. Right, now that we have that, I'm gonna do the mole ratio of what I have and what I'm looking for, but the answer is gonna be moles. So it's gonna be methane is to carbon dioxide, and the ratio between them is 1:1. 1:1, and then what do we have? It's the carbon dioxide, it's 62.5, and then if it's 1:1, it's going to be the same, it's 62.5, right? And then I'm going to change this number of moles. Now that we have an answer, this number of moles into mass. Number of moles is to mass over molar mass, right? So it's 62.5. The mass, we want the mass, and the molar mass of the methane is what? It's 12 for carbon and plus 4 hydrogens. So if you times that, if you punch that in the calculator, the mass of what? Of CH4, it's gonna be 1000 grams, right? So you can leave it like that, or you can leave it in kilograms, since they're giving you in kilograms. But I think the standard international unit should be grams. I don't think that's the reality. Right, we are done with that. Okay, question 3, hoping this is not going to disturb us. Question 3 is the physical properties. It says the boiling point of 4 organic compounds at a specific pressure are compared, right? We have these compounds here, but looking at these two compounds, they are alkanes, all of them. It's pentane, it's butane, it's not butane, it's 2-methylbutane and 2,2 dimethylpropane. So what's the difference here? It's branching. These are becoming more branched. This is a straight chain, and then it's branched, and it becomes more branched. But looking at the boiling point, as they're becoming more branched, the boiling point, what is happening to the boiling point? It decreases. That means the intermolecular force is becoming more branched. It's what? It's decreasing. So the surface area here, it's decreasing. As it's becoming more branched, right? So these are comparable, and these two are also comparable. This is pentanal and the butanoic acid, right? So this is an aldehyde and this is an acid. Okay, let's go to the questions. Right, 3.1, define the term boiling point, guys. Exam guideline. The boiling point, it is a temperature. You must state that it is a temperature. It is a temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. Right, very important. Look at the exam guideline. I might make a mistake as well by paraphrasing it. Okay, right, it says consider compounds A to C. If you're looking A to C here, we have alkanes, but they're becoming more branched, which is decreasing the surface area and decreasing in the boiling point, as you can see there. The one with the strongest intermolecular force is that, and followed by this, and the weakest is this one, right? You can see from the boiling points there. Now it says fully explain the trend of the boiling point from A to C, right? From A to C. So as you can see there, guys, given the same homologous series, which is alkane, in a 3.2.1, how are you going to answer that to explain that the trending boiling point? You can see it's increasing there, and we're given 4 marks, so it needs to be 4 points, right? It's decreasing the boiling points there. So the first point there, it's going to be what? You talk about the structure. What do I mean about the structure? You are talking about what is happening in their structures there. So in the structure there, as you can see in the structures there, there's an increase in branching. So what you can say there, you can say increase in branching, right? Increasing in branching, or you can say as they go down, they becoming smaller and smaller, they're becoming more branched. There's a decrease. There's a decrease in what? Decrease in surface area. There's a decrease in surface area, or you can say they are becoming more spherical. More spherical. I'm not sure if I write it that, but stick to these ones, guys. Stick to these ones. They are more easy. All right, 1 mark. And another mark, what are you going to talk about next? You need to talk about the strength of intermolecular force. Strength of IMF, right? Strength of IMF. So what are you going to say from A to C? There's no need to say A to C, guys. They already told you from A to C. There's no need to say A to C, A to C. Not unless you're doing the opposite now, from C to A. You can state that, right? From A to C, the intermolecular force are becoming weaker. You will say weaker what? Intermolecular force, right? Weaker intermolecular force, which is, what is the intermolecular force of those? It's London, right? You don't have to say that. You don't have to say it's London. Now the third step here, you're going to talk about the energy, right? You're going to talk about energy. When you compare such things, guys, this is how you compare. Look at my other videos, right? From A to C, they have a weaker intermolecular force, so that means they need what? Less energy required to overcome the intermolecular force. Don't say to break the bond, guys. It's not less energy required to break the bond, it's lesser energy to overcome the intermolecular force, or to say to overcome the intermolecular force, or to break the intermolecular force, not to break the bond. Then what are we going to say about the last point? Because it's 4 marks. We have. So that means we're going to talk about the boiling point. The boiling point. So what's happening to the boiling point? Therefore, the boiling point what? Decreases. You can see. You can say therefore the boiling point decreases. Right? That's the last point. We're done with that. Let's go to another question. Which one of the compound will have the which one of the following compound has the highest vapor? So the one with the highest vapor, guys, is the one with the lowest boiling point. So it's gonna be C. So the answer is C. The answer is C. So it says explain your answer. So the explanation of your answer, it's gonna be lowest boiling point. This one, C, it has the lowest boiling point there, right? It says compound D and E are compared. So D and E, as I told you, this is an aldehyde, this is an acid, you can see. Now it says, is the boiling point of E greater than or equal, smaller than or equal to than 103? We're comparing these two, right? This one, guys, has the strongest intermolecular force, so its intermolecular force is going to be greater, and the intermolecular force of this compared is going to be weaker, because this one is a dipole, the intermolecular force is the dipole, and this one is the butanoic acid, is the hydrogen bonding. You don't have to say it's a two-side hydrogen bonding, because this one is not a hydrogen bonding. You compare by sides if it's hydrogen bonding in a case of alcohol and acid, right? Now with the answer there, it's asking, is going to be smaller or D? Is the boiling point of E is going to be smaller, is going to be greater? So the answer here is greater than, right? It's going to be greater than. Now we have 3 marks. Now we have a 1 mark for that and 3 marks to explain that. That means you need 3 points for that, right? 3 points for that. So we're comparing those two. So guys, if you compare the compounds of different homologous series, you need to state their hydrogen, their intermolecular force. So what's the question there? It's 3.3. So 3.3, you're going to say 3.3, you're going to say there, okay, the answer, let me write it again. It's greater than, that's the 1 mark, and then the point, you will say D, which is the D, which is, it's an aldehyde. What is the intermolecular force? You say it has the dipole, it has the dipole, right? Dipole force, right? And then you say let's make it E, it has hydrogen bonding, which is, it's a hydrogen bonding, which is the acid, the hydrogen bonding, right? And then the next point you compare, it's 3 marks. You get the mark for that, you compare, you say you compare the intermolecular force. Now which one is stronger? So you say hydrogen bonding is stronger than London. No, not London. Then dipole. Right? Hydrogen bonding is a type of a dipole, but it's a stronger dipole, right? Or you can use energy here. You will say compound E will need more energy. It will need more energy. To overcome the intermolecular force, right? Okay, guys, we're done with that. So it's 3 points. You can see it's 1, 2, 3, or 3, right? Okay, let's go to 3.4. It says, is this comparison in 3.3 fair? So are we fair by comparing these two? Let's see if we have the experiment or the comparison, it becomes fair if we have one independent variable. So let's see. So the independent variable here is the what? Functional, the functional group, or the homologuses. What makes them different? It's an independent variable. So that's one. Let's look at their masses. Are their mass comparable, or are they mass the same? The butanol, its mass, I'm not going to waste time on that. The pentanol, its mass is what? Is 86, and the mass of that is 88. the molar mass, guys. The molar mass is 88. So the 86 and 88 are comparable. So the molar mass is not an independent variable, right? It's not an independent variable, it's a control variable. So there's one independent variable there, which is the functional group or the homologous series. So the answer here is this comparable fair? Yes. And you can say there's only one independent variable, which is the what? Which is the functional group or homologous series. Masses, very important. Masses are comparable, or you can say their masses are the same. Okay, guys, we going to question 4 now. Let's look at question 4. Question 4 is the reactions. The following diagram shows the step in preparing of an alcohol from compound Y, which is a saturated hydrocarbon. So compound Y, if it's a saturated hydrocarbon, they say here saturated, that means it's going to be an alkane, right? So here, reaction 1, it's halogenation, so it's a substitution. It's a substitution, right? Substitution of the halogen there, right? And then compound Z, that will be a haloalkane. This one is going to be a haloalkane. This one is an alkane, right? And then reaction 2, it's an alkene. That means reaction 2, it's a what? It's an elimination. It was a haloalkane, so that halogen there and the hydrogen is removed, so this is going to be what? A halogenation. So the hydrogen from here and the halogen is removed and it become an alkene, right? It become an alkene, and then going this way, this alkene, and then water is added and become the ethanol. Okay, so if water is added and become the ethanol, what is an ethanol? An ethanol is going to be this with the OH. So this simply means here, simply means this alkene, it was this, right? It's an alkene, which is, it's an ethane, right? Simply means that this haloalkane, it was this, right? And with the Br there. So this means this alkane, it was the compound Y, it was a ethane, and this ethane, the one Br is added there and is substituted. One Br is substituted there and removing the hydrogen, right? So this was an alkane, and it becomes the haloalkane, which is, this is a what? This is a substitution reaction, right? And it becomes the haloalkane. So from this haloalkane, there's an elimination, the dehydrohalogenation, which is the Br and the hydrogens are removed, and then it becomes the alkene. And then from this alkene, water is added, which is the OH, and the hydrogen, right? And then in compound X, there's a compound X that is added in this reaction, and that gives you that. So only compound that this it can be, it's a what? It's an ester, right? It becomes an ester. So this guy's reaction, I didn't tell you, it's an addition. It's an addition. It's hydration. It's addition of water. Okay. Looking at this compound X with this ethanol, with compound X, it give you an ester. It should be an acid, which is a carboxylic acid there, right? So this compound X there, so which, okay, if you're looking at this ester, it has 3 carbons, right? It has 3 carbons, but you had the ethanol with the 2 carbons. So that means this acid that is added there, it's what? It's methanoic acid. Methanoic acid, it's an acid with 1 carbon. And then when you add the methanoic acid, with an alcohol, it will give you this ester. Alright, let's answer the questions. Explain the term halogen, the halogenation. Halogenation, guys, is a reaction of halogen with a compound. It's there in the exam guide now. A reaction of a halogen with a compound, right? It's there in the exam guideline, guys, but it's rare to ask these questions. But you need to know the definition of this. What is an addition? What is a substitution? What is a, you need to learn this definition. For reaction 1, this one, I said it's a substitution. Write one reaction condition. The reaction condition for this substitution, guys, here, when you substitute, it's what? It's heat. It needs heat to do that, to come from the alkane and substitute the Br and gives you the haloalkane. It needs heat, guys, right? Heat or sunlight, right? Any form of energy there, or you can say UV light. Just one there. The formula of inorganic product. What will be the product that will be formed there? The product. So aren't we substituting? We're taking the hydrogen away there, and we're substituting with 1 Br. So there will be this hydrogen with this Br that is going to remain there. So they will form what? HBr. So it's what? It's HBr. It's hydrogen bromide, right? They said formula. Now it says 4.3, the reaction to write down the balance equation for the condensed structural formulae. So 4.2.2, we coming, they want the condensed structural formula from this one to this one, all right? From this haloalkane to this alkene, right? Guys, this type of elimination reaction, right? This type of elimination reaction here, reaction 2. So you need what? You need a strong base there. It's 4.3. We have a haloalkane, which is there, this one. So that one is going to be CH3 with a CH2Br, right? This is the compound, guys. The bromoethane. And then what do? You add any strong base there. Strong base there. So it'll be that, or it can be that, right? Or it can be lithium hydroxide. And then what's going to happen? What was our product here? Our product was a what? An alkene, right? Because you eliminated the Br and the hydrogen. So it's going to be an alkene. In alkene, it's going to be CH2, CH2, which is this one, CH2, CH2. And then, yeah, and then the product, what will be the product there? So, this Br plus this hydrogen will form this Br with this hydrogen will bond with the sodium. There will be a bond. Okay, let me just show it. So this Br that is removed there, it will be Br minus, and the sodium, it will be sodium plus, and the OH, this OH, it will be OH minus. Let's say we use that one, right? And there's a hydrogen that is removed there, which is H plus, right? There's this hydrogen that is removed there. So what's going to happen here, guys? This and this will bond, so it will be sodium bromide, right? And then these two will form what? Water, and there will be water there. Guys, I hope I'm making sense there. It says 4.3. Write down the name of reaction 3. The reaction 3, I've already written the name. It's an addition, it's a hydration, because we're coming from an alkene and we add water, so it becomes an alcohol. It's a hydration. It's an addition or the hydration. It's addition or the hydration, right? Now let's go to, it says in reaction IV, which is reaction 4, this one, I've told you this one, we are producing an ester. So that means this type of reaction, it's an esterification, guys. We're adding the carboxylic acid in this alcohol. It's an esterification, okay? It says now, in reaction 4, this compound, which is an ester, is formed when an ethanol reacts with compound X. Remember the compound X, I said it's what? It's a methanoic acid. It's an acid. It says write the IUPAC name of compound X. The IUPAC name of compound X, guys, let me re-explain again. It's the alcohol, which is the ethanol with 2 carbons, and then the product, which is an ester, it has 3 carbons. That means there's an additional of 1 carbon coming from an acid, so which is going to be what? Methanoic acid. So the name of that, it's going to be what? A methanoic acid. The IUPAC name of that, methanoic acid, right? It says write down the name of the reaction IV. It's esterification or condensation. It says use the structural formulae, write down the balance equation for this. Okay, that's where you're going to see that, guys. 4.7, it's this alcohol, which is the methanoic acid, no, the methanol, sorry. Guys, I'm leaving out the hydrogens, right? Okay, I just written them. It's not what I'm doing. Okay, it reacts with the what? With an acid. I said the acid, it's what? It's methanoic acid. It will be 1 carbon with 1 carbon with an OH and the hydrogen there. This is methanoic acid, guys. If you look at the functional group structure, it's a carboxyl group, right, with 1 carbon. So they react these two under heat and using the sulfuric acid. So what's going to happen? It's going to form what is going to be removed. It's that and this hydrogen. So we're removing this water. This is water. So we're minusing, we're removing that water there. So it's going to be that. It's going to be that, which is, it's this part of an alcohol. This part of an alcohol, it becomes an ethyl. The alcohol becomes an ethyl, and then there's this oxygen. This is going to be that oxygen, and then it's going to be this part, the carbonyl with the hydrogen. So it's like that. But one thing that you need to not to forget is this water that is removed. It's part of the product, which is the byproduct there. Guys, I hope this makes sense. Right, question 5, guys, which is the reaction rate. It says grade 12 learners use the reaction of calcium carbonate with an excess of hydrochloric acid to investigate the relationship between the concentration and the rate of reaction. Right, the balance equation for this is that it's the calcium carbonate with an acid. It gives you the salt and the carbon dioxide and water. Right, it says they conduct the experiment twice. There are 2 trials for that, and then it says each with a different concentration of hydrogen. So what is changed there? It's the concentration of hydrogen, very important. A decrease in mass in the flask, and the content is represented in the table below. So guys, here we have what we call, it's a mass meter. We have what we call, it's a mass meter, and then we're going to have a conical flask. Wow, my conical flask. Here there's a what? There's a calcium carbonate reacting with what? With HCl, right? So that was added there. So what is happening? This starts with a mass of what? If you're looking here in the graph, it starts with the mass in experiment 1. It starts with the mass of what? 270, and then the mass after 30 seconds it decreases to that. After 60 seconds it decreases to that. So every 30-second interval there's a mass decrease there, up until, if you're looking there, the mass is constant. That means the reaction has what? Reached completion starting from 150 seconds. So what causes the mass to decrease there is the carbon dioxide gas that is liberated. So there's a carbon dioxide that is released there as a gas, so that's what causes this decrease. And then another one, it was done with the same mass of 270, but if you're looking here at 30 minutes, it's 269, and then it decreases, and then look at the reaction when it stops. It stops where? It stops at 120, right? It stops at 120, and then the mass is constant there. But if you look at this one, it stopped when? It stopped at where? At 150, after 150 seconds, right? All right. Now, guys, you see, and as you can see in this one, in these 2 reaction, in these 2 trials here, there was a change of hydrogen, there was a change in concentration of HCl. So you can easily see which one that was done in a higher concentration of what? Of HCl there. Which one it was done in a higher concentration of HCl. So the one that was done at a higher concentration of HCl, it's gonna be the experiment with the mass decrease, with a greater mass decrease. Look at the 30 minutes, 30 seconds. it was that, and it was that. Do you see this one? There's a greater decrease compared to of mass with that one. Look at 60 seconds. The mass of that is smaller than this one. Do you see? It's always smaller. It's always smaller, right? So it's going to be this one that has a higher rate, the experiment one that has a higher rate with compared to that one. Okay, let's answer the question. Write down the name of an apparatus using to measuring the mass, which is this one. That one is a mass meter. Is a mass meter, or you can say it's a what? It's a scale. This measuring mass here, the mass is 120 what grams. They write down the name of the limiting reagent. We're told there that the HCl, the learner reacts the calcium carbonate with an excess of HCl. So the HCl is an excess. That simply means that the calcium carbonate, it needs to be the limiting, right? It says define the term reaction rate. The term reaction rate, guys, here it's the definition, guys, you need to know it's a change in concentration of product or reactant per unit time. Guys, I'm not gonna write that. Experiment one calculated the rate of reaction in mole per second. Very important, in the first 30 seconds. So for experiment one, which means we're going to look at this one, right? It says calculate the what? The rate in what? In mole per second. But what we have here for the first 30 seconds, we're coming from 0 to 30, so we're going to look at that time, right? And then our masses there is those two masses. That's the first 30 seconds. So this is the initial mass and this is the final mass, right? That's the final mass. But now we have masses, and it has to be what? It has to be, guys, these masses are going to be mass. This change of mass is the mass of what? Calcium. Is the change of mass of what? Carbon dioxide. This is the carbon dioxide that is released there. So the difference here is the what? Is the carbon dioxide. So in 5.4, what is the mass final? The mass final is this one. Is 268,4 minus the mass initial, which is what? It's 270. So the answer there, it's going to be 1.6 grams, right? Yes, it's gonna be negative, but I'll show you why is it negative, right? And then we change, since they said they want in mole per second, so the difference in the masses here, it's 1.6. So our rate, it's going to be change in number of moles divide by the change in time, because it must be what? Mole per second, right? So first we need to change this this mass into number of moles. So the number of moles of carbon dioxide is equal to mass over molar mass. So it's going to be 1.6 divided by the molar mass of the carbon dioxide is 44, which is it's 12 plus 16 times 2. So it's 60. It's 1.6 divided by 44, which is going to be 0.0 3. That's what I get from the calculator. 3636 mole, right? That's the carbon dioxide mass, which is, that's the change. It's the carbon dioxide that is released in the first 30 seconds. And then we come here, so when we come here, we are going to use this. We're going to use this mass, right? This number of moles, sorry, don't know what's wrong with me. This number of moles, which is, we're going to use that. So from this, we have the number of moles. We're going to need what? Time there, right? So we're going to say 0.03636, right? And then we divide by the time. What is the time there? It's the what? It's the 30 seconds. From there to there, it's what? It's 30 seconds. So we divide by 30. So it's going to be the answer, when you punch that in the calculator, it's going to be 1.21 times 10 to the power negative 3, right? Negative 3 mole per second. That's your rate. Guys, that's not the only way to do that. That's not the only way to do that, right? You can you can do it in two ways. First, which is the alternative, that you have this mass initial, this is the mass final and the mass initial. So what you can do, you can, okay, let's do the alternative. For that, you can change those masses, and change those masses. It's mass of carbon dioxide. Let's say this is the initial. It's mass over molar mass, which is, you're going to say 270 divided by 44, right? It's gonna give you an answer for that. Okay, let's punch it quickly. It's 270 divided by 44. It's 6.136 mole. That's an initial. And then your final, it's 268.4. And then the number of moles of carbon dioxide, which is the final now, it's the mass is what is that mass? It's 268.4. 268.4 we divide by 44. 268.4 divide by 44, it's 6.1 mole, right? And then we can go to the formula of a rate. We can say rate is equal to change in number of moles over change in time, right? If you're looking here, since we are doing the product, it must be what? Negative our rate. So it's going to be number of moles final minus number of moles initial, T final minus T initial, and then you put the negative there. Why do you put the negative there? You can see that your final is smaller than your initial. So there's going to be a negative number of moles, so you need to put the negative in front. Look at my other videos, it tells you that. And then it's going to be negative what? What is our final? Our final is 6.1. Negative 6.1 minus the initial, which is it's 6.136. And then the time, the T final, it's what? It's 30 seconds. The T initial, it was what? It was 0 minus 0. So it's going to be the same answer, which is 1.21 times 10 to the power negative what? 3. What? Mole per seconds, right? This is the easy method. This one, it's a straightforward method, this one, right? Let's go to the next question. 5.5. In which experiment did the learner use a higher concentration? As I've mentioned there before, it's experiment what? 1. It's experiment 1. Experiment 1. Right? It says use a collision theory to explain your answer. So using collision theory to explain my answer, what was changed there? It was a concentration. So when you talk about the concentration there, you need to say at higher concentration. Higher concentration, guys, it gives you higher concentration um, there's a higher concentration, there's a more particles, let me write it here. Higher concentration, there's what? More particles. When you increase the concentration, there are more particles that you increase. There will be more particles per unit volume. Guys, concentration formula C is equal to N over V. So if you increase the concentration, there will be more number of particles there per unit volume, right? There will be more particles per unit volume, and then secondly, you'll say there will be more effective collision per unit time. Very important to don't just say more effective collision. You need to say more effective collision per unit time, right? And then lastly, there will be what? A higher. Remember, it's 3 marks that you need to state this, and whenever you talk about the concentration, guys, there must be the particles per volume, and always the more effective collision, it's there. And then now, since there's a rate is higher, you need to state there and say a higher rate of reaction. There will be a higher rate of reaction there, or you can say there will be a higher rate of what? Of production of what? Of carbon dioxide. There will be more carbon dioxide that will be released today. Guys, this question, I hope it makes sense. Cheers. Chemical equilibrium question 6. Let's look at it. It says ammonia gas is produced by pouring nitrogen gas and hydrogen gas in an empty container and allowed to react in a closed container according to the following balance equation. Sorry. This is a nitrogen gas and hydrogen and produces the ammonia, right? Right, we are given here the graph of rate of forward and reverse indicated. So this is the graph of rate versus time, right? This is the rate of reverse and the rate of forward, right? At point A, that's when they're at equilibrium up until point B, and there was a disturbance there. And then here at point C, and then it reinstated the new equilibrium, and then there's another disturbance there, but we'll talk about it, right? Okay, let's talk about it now. These two, they're moving up together at the same time, and then they become at equilibrium at the same time there. So this simply means that this is a pressure. No, sorry. This is a what? This is a catalyst. So there's an addition of the what? Of the catalyst there, right? And here, if you're looking at this, there's a decrease there in the rate. There's a more decrease in both rates. But if you look at the reverse decreases more. That means the reverse is not favored there. The one that is favored is forward there. So it simply means that this, if you look at the decrease there, so immediately the forward is taking the curve, which is the gentle curve there, and then the reverse is going straight down. So this means that it's a what? It's a decrease in temperature. That, so it's an addition of catalyst, and this is a decrease in temperature. Both of them are decreasing. That means it's a decrease in temperature. So here forward is favored and reverse is not favored there. I hope that makes sense. Let's go to the questions. Now the first question, it says define the term chemical equilibrium. So the chemical equilibrium, guys, you look at the exam guideline. I'm just going to say it is the rate of forward reaction is equal to the rate of reverse reaction. It is the rate of forward reaction equal to the rate of reverse reaction. Now it says here 6.1.2, identify the change made at B. What is the change that is made at B there? As I've mentioned, it's an addition of catalyst. Addition of catalyst. right? Now it says when there was a temperature change at C. Do you see? They're telling us at C there's a temperature change there. All right. While the pressure was kept constant. Now A, it says what did the temperature change? Write down only increase or decrease. So the temperature change here, as you can see, as I've mentioned, there's a temperature decrease because both rates are decreasing, but there's one that decreases more and there's one that decreases less. So that's a temperature decrease there. So it's a temperature decrease, right? Now it says, is the forward reaction endothermic or exothermic, right? So this the forward reaction here is what is favored, as I've mentioned here, because the forward, this one, there's a lesser decrease, and in the reverse there's more decrease, and the one that is a lesser decrease is the one that is favored, which is forward. So is it exothermic or endothermic? So always theoretically, guys, you use the theory. The temperature decrease is what is exothermic. So the answer here is what is exothermic there, right? C, use Le Chatelier's principle to explain the answer, the above answer in 6.1.3b. So in decrease in temperature, that's very important, decrease in temperature favors what? Exothermic reaction, right? It's very important. That's the point. A decrease in temperature will always favors the exothermic reaction. And which reaction was favored in this decrease in temperature? It was what? Forward. So we'll say forward reaction is favored, right? Or you can say the rate of forward reaction, it decreases less. As I've mentioned, the rate of forward reaction decreases less than the rate of what? Reverse. By saying that, you are meaning that it is favored, right? 6.2. Now it says a decomposition of nitrosyl chloride is represented below. So decomposing, they're splitting this into two compounds, right? To 2 mole of decomposing 2 mole of nitrosyl chloride into 2 mole of nitrogen oxide and 1 mole of chlorine gas. Now it says at a temperature of 50 degrees, 4 mole of nitrosyl is placed in 2DM3 container. This is the initial, right? This is initial, and this is the volume that it was placed in. Now it says at equilibrium, right? It is found that 0.9 of nitrogen oxide was formed. So after all these reacting, the 0.9 mole per dm3, that's the concentration, was formed. Now let's use the Kc table, right? Okay, before we use the Kc table, I'm rushing. Now 6.2.1, it says define the term reversible reaction. So when the reaction is reversible, guys, it means the product can be converted back to reactants, right? Now stick to the exam guideline, guys. I'm not going to write that. 6.2.2, it says calculate the Kc at 50 degrees, right? Now let's place what we have, what we are given to in the table, right? Now it says 4 mole of nitrosyl chloride, its initial. So here's the nitrosyl chloride, guys. I'm using the rice table. Our ratio here is 2:1. Where do we get that? There, right? So the 4 mole, I'm placing it there. And what was there initially for the products? There was no product. It's going to be 0, 0. Then we're given the 0.9 mole per dm3. That's the concentration at equilibrium. The concentration at equilibrium, it's at the end. It's 0.9 there. So now, how do we fill the other parts of the table? So this is the concentration. This is the concentration. So we have to change this concentration into number of moles there. So what do? We use the formula that says number of moles is equal to CV, and then we'll take the concentration, which is 0.9, we times it by 2, which is going to be 1.8, and then we put the 1.8 there, right? So in this table we can use other trick to get these values here. So we are going to say this is 2xy because this is 2 mole of nitrogen nitrocell, so it's going to be 2x, but it's going to be negative 2x. And then this is 2 mole of nitrogen oxide, it's going to be positive 2x. Why? It's a product. And this one, it's 1 mole, which is 1 mole of chlorine gas, it's going to be plus x, right? So how do we get these values here? Normally in the product we say what was there initially and what was formed, and this is what is at equilibrium, right? This is what remained, this is what is formed. So we're going to say 0 plus 2x is equal to that. So 0 plus 2x is equal to 1.8. Therefore 2x is equal to 1.8. So what do we want here? We want 2x. 2x is what? Is 1.8. So we're going to have 1.8 there. Normally you say 0 plus 1.8 is 1.8, right? So if 2x is 1.8, what will be x? It's a half of this. Half of 2x is x, and half of 1.8 is going to be 0.9. So the answer there is 0.9. So if this is 2x, this is also 2x, that means that this is also 1.8, right? So what are we going to do now? We normally say 4 minus 1.8, it's going to be 1.1. And then here it's the product, we say 0 plus 0.9, it's going to be 0.9, right? It's going to be 0.9 there. And then now we have the number of moles at equilibrium, and most especially these we have to convert into concentration. We use the formula that says C is equal to N over V. So that means we divide by 2. Our V, it's 2, the volume, so it's going to be 0.45. When it says 0.9 divided by 2, it's 0.45. And then this, when we no guys, I've made a mistake here. Since I've done this before, I know the answers. So we say 4 minus 1.8, it's gonna be 2,2, right? And then when we divide, we change this into concentration, we have to divide by 2, it's gonna be 1.1. So that's why I had the 1.1 there, because I know the answer there is going to be 1.1. And then calculating the Kc, we'll say Kc, it's the product, concentration of product. The product, it's a nitrogen oxide to the power 2 times the concentration of chlorine gas to the power 1, right? And then all divided by the concentration of the reactant, which is the nitrocell chloride to the power 2, right? There's a 2 there. Okay, so let's substitute now our concentration, which is these, right? So the nitrogen oxide is what? It's 0.9. It's 0.9 to the power 2, and the chlorine, it's 0.5, 0.45, and all divided by the concentration of nitrocell. It's going to be It's 1.1 to the power 2. 1.1 to the power 2. So the answer here, it's 0.30. That's our case there. And we are done with that question, right? Question 7, which is the acids and bases, right? It says, according to the balance equation below, a dilute solution of hydrochloric acid is used in titration against the ammonia. Here's the reaction below. It says the HCl ammonia give you ammonium chloride. Before anything, you go there and identify what acid is. Hydrochloric acid is a strong acid. You need to memorize the list of strong acid and the list of the strength of acids and the strength of bases. Ammonia is a weak base and it gives you that salt, right? Okay, now it says define the term hydrolysis. Guys, exam guideline, do not paraphrase this definition, say it exactly as it is in the exam guideline. So the hydrolysis is a reaction of salt with water. It is a reaction of salt with water. I'm not going to write that. Now 7.1.2, will the final solution be acidic or basic? Right, guys, I've done the video of the hydrolysis, right? So if there's a reaction of a strong acid and a weak base, whatever it was a strong and the weak. What is strong? It's going to be the salt. So what is strong between the two is the acid. So that means this salt is going to be acidic. So the answer here is acidic, right? And it says, right, the balanced chemical equation that explains your answer. So what will explain my answer, guys? You take the ammonium here, the ammonium ion. This gives you what? This comes from the ammonium ion plus the chloride ion. So you take the weak part there. For an acidic, you take the cation. So it will be the ammonium. You take the ion, the ionic salt, and you dissolve it in water. So if you dissolve it in water, it's gonna give you, this is acidic, right, with water. So it's going to give you, this is going to donate a proton there, so it's going to be ammonia, and then this is going to be what? A hydronium ion, right? So that's what is going to happen there. This is the equation that they want. This is what explains the hydrolysis. So by adding this salt in water, and it gives you that, it's a hydrolysis. And what proves this is acidic. This is an acidic salt. It forms what? The hydronium ion. 7.2, it says, for the above titration, 25 cubic centimeter of 0.1 mole DM3 of ammonia is titrated against the 40 cubic centimeter of HCl, right? So there's a titration between the two. Now they said 7.2.1 is HCl a strong or weak acid? So HCl is a strong acid, right? In 7.2.2 it says explain your answer. Always, guys, when you explain your answer, it's an acid, it ionizes. All the acid ionizes, and if it's a strong acid, it ionizes what? Completely. It ionizes completely in what? In water. So if you add an acid in water, it ionizes it completely, more especially it's a strong base. And don't forget this. Don't just say it ionizes completely. You say it ionizes completely in water to form a high concentration of hydronium ions, right? That's how you say it's a strong base. So if it was a weak a weak acid, we're going to say it ionizes incompletely in water to form low concentration of hydronium ion. Okay, right? It says write down the name of the indicator that most suitable for this. Guys, for a strong acid and a weak base, you use a acid that is a what? That is called a methyl orange. Methyl orange is for a strong acid and a weak base. So it says explain your answer why you chose that. This is a reaction of a what? Strong acid. Or you can say it's a titration of a what? Strong acid and weak base, as I've mentioned. Now, in 7.2.1, it says calculated the number of moles of ammonia in 25 mole DM3. So 7.2.5, we wanted the number of moles of ammonia. So the number of moles of ammonia, we use the formula that says C is equal to N over V. We substitute the concentration there of ammonia we have. It's what? It's 0.1. So it is 0.1, we substitute in the concentration and we want the number of moles, and then our volume there it's 25. So if we divide 25 by 1000 to convert into DM3, is going to be 0.025, right? And then we cross multiply the number of moles of ammonia there. It's what? It's 2,5 times 10 to the power -3 what? Mole. That's the concentration of the ammonia there. Now the last question, it says calculate the pH of the final solution if the concentration of the original HCl was that. So guys, what we are going to do here, in 7.2.6, we have to calculate from, isn't it that the acid is titrated with this, right? So we got the number of moles of this, right? So this is now the initial number of moles. So this number of moles are the initial number of moles of what? Of the ammonia. So we can use the initial number of moles of ammonia to get the amount. We're going to use the initial of ammonia. The ratio of initial is to the ratio of what? Of the amount what? Reacted, right? So we're going to use the ratio of what? Ammonia is to HCl. So what is the mole ratio between them? Is 1:1. So we're going to say 1:1, and we're looking for the HCl. What is the ammonia? The ammonia is 2.5 times 10 to the power -3. And then if the ratio is 1:1, so that means the X is 2.5 times 10 to the power -3 mole. That's what? That's the amount of what? Of NH3. NH3, not NH3, the HCl. That's the amount of HCl what? Reacted. Right? That's the HCl reacted. So from this HCl reacted, what are we going to do? We're going to change it into concentration. Why? I'll show you shortly. So I'm changing this concentration reacted, this number of moles, into concentration. So we say C. So this is the concentration of what? Of HCl. Concentration of HCl what? Reacted. Right? It's a concentration of HCl reacted. The number of moles is what? Is 2.5 times 10 to the power -3 divided by the volume. What is the volume? The volume of the HCl, it was what? 40. So we put the volume of HCl. So but 40 we have to convert, you divide by 1000, it's going to be 0.04, and then when you punch that in the calculator it's going to be 0.0, or we can say, put it in the sign, it's 6.25 times 10 to the power negative 2, right? 6.25 times 10 to the power negative 2 mole per dm3. That's the concentration of the HCl reacted. Now we have the initial concentration of the HCl. This was the initial. So we want the pH. So getting the pH, we must get the what? The excess. Getting the excess, we have to take the initial and minus the amount what? Reacted. So we'll say concentration of HCl. Okay, let me put it like this. Concentration of HCl what? Excess. We say concentration of HCl, which is the what? The original or the initial, minus the concentration of HCl reacted, right? The original, it was what? 0.1. So the 0.1 we minus the what? The 6.25. 6.25 times 10 to the power negative 2, that was the reacted, and it gives us the amount. When you punch that in the calculator, it gives you 0.0375, which is, it's 3.75 times 10 to the power negative 2 mole per dm3. So this is the concentration and excess of concentration. Remember, the pH of the final solution is calculated by the excess. So we will say now we have the concentration of the HCl. Concentration of the HCl, which is the excess, right? So we'll do the mole ratio. Since the hydrochloric acid, it's a monoprotic, that means its hydronium, it's the same concentration with the hydronium, right? So the concentration of the hydronium, it's going to be the same as the concentration of the HCl, right? So that if that's the case, we can calculate the pH by, say, negative log concentration of hydronium is equal to negative log, and we take the hydronium, it's 3.75 times 10 to the power negative 2, and then the answer there. So if we punch that in the calculator, it's gonna be 1.43. That's the pH of the final solution there. I hope, guys, that makes sense. Let's look at question 8. Question 8, it says, it's a galvanic cell. It says the following balanced chemical equation represents a reaction that takes place when a galvanic cell is in operation under a standard condition. The initial reading on the voltmeter, it's 0.14. Right, we are given the net cell here. This net cell, if you notice, we have a chloride ion and the gold ion that produces the chlorine gas and the gold in the solid state. But if you really pay attention in your table, the standard reduction potential table, there's no gold here. There's no gold. Gold doesn't appear. What's going to help us to note which one between the chloride ion and the gold ion that reduces or oxidizes? It's the oxidation number. We have to assign it the oxidation number. The chloride ion, its oxidation number, it's -1, and the gold ion, it's +3. And then we go to a chlorine gas, it's 0. And then we go to a gold, it's 0. Now, if you look at the oxidation number from chloride ion to a chlorine gas, there's an increase in oxidation number. So this is undergoing the what? In oxidation. So chloride ion, it oxidizes, right? And then if you look at it, the gold ion to the gold, there's a decrease in oxidation number from 3 to 0. So this undergo the reduction, right? Very important. It says write down 2 standard condition under this cell operates. So it's going to be, we're going to take the temperature. The temperature is 25 degrees Celsius, and we can say maybe the pressure, because there's a gas here, there's a chlorine gas here, the pressure, it will be 101.3 kilopascals, right? Or you can take any two with the concentration as well, including the concentration. Now it says write down, for this cell, write down the name or the formula of the electrolyte that can be used in the salt bridge. So the electrolyte that can be used is in the salt bridge, guys, it will be, we can say, the name or the formula, we can say, we can use the potassium nitrate, right? Or we can use the any soluble salt. Potassium nitrate, we can use potassium sulfate, any soluble salt there, you can use it. All right, it says write down the reducing agent. The reducing agent is the anode, is the one that oxidizes, which is a what? It's a chloride ion, right? It's a chloride ion. You can write it like that. Okay, the cell notation now, guys, we know this one oxidizes, this one reduces. So if you look at the chlorine, the chloride ion, it gives the chlorine gas. So if there's a gas that's involved, that means there must be an electrode for this. It's a what? It's a platinum. It's something like this. It's something like this. You have here the platinum in that, and then there will be a gas. So this is the platinum, the PT, and then there will be a chloride ion there, and then there's a salt bridge. Guys, I'm not drawing this correctly. Let me draw it again. A little bit bigger. So you have 2 beakers, and then this beaker will have a what? Will have an AU, and then it's connected with that, and then there's a voltmeter there, and then in this one we'll have what we call an electrode, which is the platinum, and then in that platinum there's a what? There's a chloride ion. There will be chloride ion there, and here there will be AU3, right? And there will be a salt bridge. So this side, it's going to be chloride ion, and then that will form the gas here. There will be a gas, which is a chlorine gas, and this will be a cathode, which is its negative, positive, and this one will be negative, which is a what? It's an anode, right? Okay, now the cell notation, guys, there we're going to have the platinum as an anode, as in the anode side, which is it's part of the electrical conductivity, and then we'll have the chloride ion, and then the change of state, and you have the chlorine gas, and then the salt bridge, and you have the the gold ion, and then this gold ion, it's reduced to the gold atom. So it's gonna be like that. The cell notation. It says calculate the standard reduction potential table for gold. So we use the formula for E cell is equal to E cathode minus the E anode, right? So the E cell, we were told the initial, it's 0,14, right? It's 0,14. And then the cathode, what is our cathode? It's the gold, right? The cathode is the gold. So I'm gonna just put it again. The cathode is the gold, and then our anode, it's the chlorine. It's the chlorine gas. The chlorine gas, it's at the bottom there, which is, it's gonna be 1.36. It's 1.36, and then we take that to that side. So it's gonna be the E, E cathode. E cathode, it's going to be 0.14 plus 1.36. It's going to be 1.5 volts. Right? We are done with the question 8. Let's go quickly to question 9. Question 9, it's an electrolytic cell. It says a simplified diagram below operates represents an electrolysis of the concentrated sodium chloride. So guys, here this is an electrolytic cell. These are the carbon rods, and then there's a battery there. So this type of process, it's a process of converting the electrical to a chemical, right? So these are the carbon rod, and this side is negative, and this one is positive. So this is a what? This is an anode, and this side is a what? Is a cathode. We see by the terminals of the battery there, right? So what do we have here? We have a sodium chloride, but it dissociated by water. So we have a sodium ion and the chloride ion and the water there. So what's going to happen? There will be an oxidation and the reduction there. So if you look at the chloride ion, will oxidize in the anode there. So this is what is going to happen. It's going to be a chloride ion that will oxidize to a chloride a chlorine gas, that's the oxidation that happens here. This is the oxidation, right? So there will be a gas that is formed, a yellowish green gas bubbles that will be formed there, right, with the sharp scent, right? This yellow gas that will be formed there. And then there's the two that is remaining. There's water and sodium. So between the two, the water and sodium, water is a stronger oxidizing agent than sodium. So it's going to be what? It's going to be reduced there. So when water is reduced here, it's going to be reduced here. So what's going to happen? The water, which is 2 molecules of water, will get 2 electrons, will be reduced, which is get 2 electrons, and it will form the what? The 2OH minus and plus hydrogen gas, right? So that's what is going to be formed. There will be a hydrogen gas that is formed there. So there will be a hydrogen gas that is formed there, right? There's a hydrogen gas that will be formed. And of course, so after this, water has been reduced. There's an OH that is going to be formed. There's an OH that is formed there, which is this OH. So the net cell for this, or the overall, it says the balance equation for the reaction taking place in the above cell is this one. It's a sodium chloride and water. It gives you sodium hydroxide, because these two are going to form a bond and form this sodium hydroxide, and then there will be gas. This hydrogen gas, it will be in the cathode, which is this one, right? And the chlorine gas in the anode, which is this chlorine gas there. Okay, let's answer the questions now. The question 9.1, it says define the term electrolysis. The electrolysis is the chemical process, guys, in which the electrical energy is converted to chemical. It's a chemical process in which the electrical energy is converted to chemical. Stick to the exam guideline. 9.2, which electrode is an anode, right? As I've mentioned there, this is an anode, which is an electrode X. So the answer is X, right? It says write down the half reaction that takes place at the electrode X. This is the half reaction that takes place at the electrode X, right? This is the answer, guys. I'm not gonna write it again, and you can get this from the table, guys. You don't have to memorize. Where's the table? Where's the table? You don't have to memorize. Do you see the chlorine? Since oxidation, you start this way and you write one arrow and it goes that way. That's what I've written there, right? So that's the answer. So this is the answer for 9.3.1. And then it says the half reaction that occurs in electrode Y, which is this one. This is 9.3.2. This is the answer there, right? And where do we get that? Where did I get that? I get it from the table as well. Where's the table? Where's water? Water is above there, which is this one. Do you see? You write it as it is with one arrow. Do I make sense, guys? I'm sure. Now it says 9.4, a very interesting question. It says a current of 0.5 is applied over a period of 5 hours. That's changing T. And it says calculate the volume, which is want the volume at STP. So STP, we know we apply the formula that says V is equal to Vm. There's a molar gas volume that is formed during this time. So if we're given the current and time, that means we can get the charge. So step number 1, what we're going to do, we're going to use the formula that says current is equal to Q over change in T. So what can we get there? We'll use the current that is 0.5 and the charge. We'll get the charge and the time there. So we must be careful. This is hours. You need to convert it into seconds. That means it's going to be 5 times what? 60, which is converted into minutes, and times by another 60, converting into hours. So our charges there, the answer, if you cross multiply there, it's going to be 9,000 coulombs. Those are the charges. Then step number 2, we're going to convert the charges into number of what? Of electrons. So we're going to use the formula of quantization of charge, which is this one, right? So we'll take the charges, which is the 9,000, we divide by the elementary charge, which is 1.6 times 10 to the power 19. So we'll get the answer there is 5,625 times 10 to the power 22 what? Electrons. These are the electrons that were transferred. And then step number 3, we're going to convert the electrons into mole electron, right? Converting the electron into mole electron. So what are we going to do when we do that? So we'll use the Avogadro, which is N is equal to N over Na, right? So we're going to take these electrons, which is it's that. So it's going to be 5,625 times 10 to the power 22. We divide by 6.02 times 10 to the power 23. So the answer, it will be 0.093 mole, right? We converted that into this is the mole electron, right? So step number 4, we are changing the mole electron into moles. So what are we going to do? We're going to calculate number of mole of chlorine gas. This one is the Mole electron is the mole in terms of electron. So what are we going to do now? How many electrons in the chlorine? It's 2 electrons. So what are we going to do? We have to, if we want to move the mole electrons into number of mole, so we'll take this answer, which is 0.093. We divide it by 2. Where do we get the 2? From the 2 of electrons there. So our answer there, it will be 0. 0. The half of that is going to be 0.465 mole. Now we have the number of moles. We wanted the gas that is produced at STP, which is step number 5. We'll use the formula that says N is equal to V over Vn. So we wanted this V. We have that. So we'll say 0.0465 equal, and the V and the Vm is going to be 22,4. So the volume of chlorine gas at STP is 1,4 dm3. Guys, you need to follow these steps, guys. I hope this makes sense. Cheers. Bye.